triangle.
Yeah, it's like the moving stairs, so that would be slanted. It goes a vertical distance of 15 feet. We have an angle of 30 degrees with the ground. So here's the ground, and that's my 30 degrees. We want to know how long the escalator is, so we're looking for this side. So we can assume vertical and horizontal, that's right angle. So from here, that's opposite and hypotenuse, so that would be sine. So we could say the sine of 30 degrees equals the opposite side 15 of the hypotenuse, which was x. Then what is the sine of 30 degrees? 1/2 equals 15 over x. If you cross multiply, you get x equals 30 in radians. There, probably the biggest thing was putting your sides on the wrong spot in your triangle. Is that one all right? This one, number 3. So we have a right triangle ABC. C is the right angle. Angle A is 43 degrees. Side C is 80 centimeters. And we need to find side B. So since it's a right triangle, we can just do SOHCAHTOA. From this angle, B is the adjacent and 80 is hypotenuse. So adjacent and hypotenuse, that would be cosine. Cosine 43 equals the adjacent side B over the hypotenuse, which is 80. I have one. The rest of them are currently in POC testing. So to evaluate this, we need to make sure we are in what mode? Degree mode. We need to multiply over the 80. So let me just type it in. 80 cosine of 43, and it's 58.5. But the direction said significant digits. So if you look at the significant digits, 80 is how many significant digits? 1. So that's why I rounded this to 60 here in centimeters for my final answer. Only because it said significant digits. Number 5. So we have person standing on top of a 13-foot high sand pile. This is 13. And we know that the angles of depression, so that's from the horizontal down, so if we draw in a horizontal, one of those is 19 degrees, the other is 25 degrees. So to find the angles inside the triangle, you do 90 minus each of those. So 90 minus 19 is 71. 90 minus 25 is 65. And our trig functions work in the right triangle. So here's the right triangle. Here's the right triangle. Our goal is to find this total distance. So what we'll do is find this side in each of those and then add them together. So in this one, from my 71, x is opposite, 13 is adjacent, so we could say the tangent 71 degrees equals opposite over adjacent. Multiply over 13. 13 tangent of 71 is 37.7547. Then we do the same thing to get y. So we can say the tangent of 65 equals the opposite y over the adjacent 13. Multiply over the 13. We get y to be 27.8786. So then the final answer, we add those together. And you get 65.6333. I said use significant digits, so all of these numbers just had 2 significant digits, so I rounded this to 66. Is that okay? Number 6. We have a 76-foot flagpole. Flagpole will be up and down. Cast a shadow 57.0 feet long. Where does the shadow go?
On the ground.
How many significant digits do both of those have? Well, I guess the original, I didn't write down the whole thing. So they had 3, so we'll answer 3 significant digits. We want the angle of elevation of the sun. So the sun will be up here in the sky. Angle of elevation goes from a horizontal up. So I'm looking for this angle right here. So what trig function would we use? Tangent theta equals the opposite over the adjacent. If you're trying to find your angle, that's when you do the inverse. Tangent inverse 76 over 57. So if I'm doing 3 significant digits, that's 53.1 degrees. Number 7. We know that sine of theta is negative 0.3060, and we are in quadrant 3. So what I want you to get is the reference angle. To do the reference angle, if you're looking for an angle, that's when you do the inverse. So we do sine inverse of the positive. And we get 17.8183. How do you put that in quadrant 3? Reference angles go from the x-axis, so you'd have to do 180 plus that. You get 197.183. Number 8, we know cotangent is negative 0.7395. Okay, we don't have a cotangent button, so we need to think about tangent for a minute. That means tangent is 1 over this. It told us we are in quadrant 2. So to get the reference angle, you do tangent inverse of the positives. So second tangent, 1 over 0.7395. Okay. Then, how do we put that in quadrant 2? 180 minus the 53.5171, and we get 126.4829. Is that okay? So next up we have number 10. So remember we had all of these formulas, they're on formula sheet, but we had S equals R theta, V equals S over T, omega equals theta over T, V equals R omega, A equals 1/2 R squared theta. Okay. So I want the linear velocity. What variable is linear velocity? V. So I'm just going to say V equals question mark. Remember when I did these, I told you it's a good idea to write out what your variables are and to write out the formula you're using. and follow your work. The distance on the outside of the circle is 45. What variable represents distance on the outside of the circle? S, that's arc length, the outside distance. And the 3 hours would be time. So if I look at these, then I can see I could do V equals S over T. So you get 45 miles divided by 3 hours. So 45 divided by 3 is 15. And then our units would be miles per hour.
So we wouldn't have to convert them?
No, because I didn't specify if it.
Okay, I was thinking I had to convert it to radians.
If you have something involving, so an omega and a theta both have to be in radians.
Okay.
But since neither of these involved an angle, we didn't have to convert anything. Number 11. So the angular velocity. What variable is angular velocity?
I want to say that.
Yeah, the omega. That's 10 radians per second. So quick check, it is in radians, so we're good. The radius is 3 feet. We want the distance traveled. So the distance on the outside of the circle is S in 4 minutes. So that's my time. Now right here, I notice a problem. Omega is in seconds and time is in minutes. I need those to match. So 4 minutes is how many seconds?
4.
How many seconds are in a minute?
2.
Yeah, so 60 times 4, so that's 240 seconds. Okay, this is going to be a two-step problem because I need S. My options for S are S equals R theta. I have R, but I would need theta. Or V equals S over T. I have S, I would need V. So we either have to find theta or V to begin with. Which one do you want to find? It doesn't matter, we just have to pick. Okay, so if we want to use the S equals R theta, first I have to go out to the side and find theta. So I could do omega equals theta over T. So omega was 10 radians per second equals theta over 240 seconds. So if you multiply over the 240, theta is 2,400 radians. So then we can come and do S equals R times theta. So you get 7,200. The units, S is a distance, just like the radius, so that would be number 13. A wheel with a radius, so R equals 5 feet, rotates 13 revolutions per minute. What is that? So how did you guys write that down in terms of variables? What did you treat that as? So we have a couple different options. We could kind of break it up and think of it in terms of an angle and a time, or we could treat it as the omega revolutions per minute. Either way we can get there. If we do that, this is 13 revolutions per minute. We want the linear velocity, so we're looking for V. Now here's the problem. This is revolutions. When I'm talking about theta or omega, it has to be radians. So we need to convert. What does a revolution mean? Okay, so if I want to get rid of revolutions, it goes from the bottom. So 1 revolution is all the way around the circle. If I want to change that into radians, how many radians is it to go all the way around the circle? So this is 26 pi radians So then we can do V equals R omega now that we have radians. So you do 5 feet times the 26 pi radians per minute. And you get 130 pi. Linear velocity, so linear would be feet and per times in minutes. So 130 pi feet per minute. What else do we need to talk about? So for tomorrow, let's do the second sheet of paper. So that's 14 through 27. You've got the rest of the hour to work on those.